What's up, guys? I hope you all are doing well. Welcome back to my YouTube channel and welcome back to another YouTube video. In this video, we will be looking at exercise 36 of our Python exercise tutorial series. So, guys, as you can see, right, this will be a video that's a little different from the ones that we've been doing. So, I was not going to actually include this exercise in the tutorial series, reason being the category or topic of this kind of question is actually a part of an entire different topic in IT, in technology, right? And basically Python is one of the programming languages that I use or that is used in this discipline, right? Call it discipline. Reason being, it's a super important IT discipline. It's called cryptography, right? Cryptography or cryptography, anything or however you want to say it. So the idea is that it has to do with encryption, and cryptography uses encryption algorithms, and we call the encryption algorithm a cipher, a CIPHER. So I'm including this exercise in the Python exercise tutorial series because it's a good time for me to actually mention that I have big plans, for the channel, and a portion or a part of that plan has to do with enlightening you on the topic of cryptography. Cryptography forms a huge part of modern day technology, especially the blockchain, if you've heard of that, as well as computer network and security related aspects. Cryptography is used everywhere. Something like our computer and our phone, basically any device that has the ability to even set a password, makes use of cryptography in some way. So with that being said, I will read this text prompt, this problem prompt. You'll get introduced to one cipher, that is encryption algorithm, kind of like a rough overview, right? And in future videos, I plan to have really insightful and interesting videos that speak, in which we have a discussion on these topics and on these encryption algorithms and so on. So let's get to it. In this specific prompt, I will not really read it. What I'll do is, since we are here at this point, I'll just give you a rough overview, right? There's this thing called cryptography, as I told you. Cryptography is a kind of a discipline that's IT based. It's an IT field or discipline, and the point is that it deals with encryption of data. Cryptography is used literally in so many places of our life, guys. Without cryptography, something like the web, the entire web won't exist. The web itself uses cryptography. Those protocols, HTTP, HTTPS, everything, VLANs and VPNs, all of these use cryptography. So with that being said, there's this encryption algorithm called Caesar cipher, right? Caesar cipher, this is how it's spelled. So Caesar, and I showed you how cipher is spelled. It's as follows. Caesar cipher, that's how it's spelled. Now that is one of the first encryption algorithms or ciphers to have ever been created in the past. Essentially, this guy, his name was Julius Caesar. If I'm not mistaken, he was some sort of ruler or something. But the point is that in the past, you see, what they used to do is their messages and so on, to avoid those. Now, in the past, they did not have devices. They used to send messages to and from the recipients and sender. It used to be all done on paper. Now, to prevent that paper message from falling into the wrong hands, or even if it did, they needed a way for the message within the paper to actually be sort of encrypted or like scrambled. So what they did, what Julius Caesar did, is that he basically took every letter of the alphabet and he shifted it three places to the left. So what I mean is that the letter A became letter D, okay? B became E, and so on. This is what he did. And this is what we call the Caesar cipher. Essentially, it shifts all letters of the alphabet 3 letters to the left. So it's as they explained in the text prompt as well. So that's fine. Nothing too difficult at all. In fact, this is one of the most interesting topics that I've learned so far in my software engineering degree. And essentially, what this Python program does is that it implements a Caesar cipher in Python. So it allows the user to enter a message, which is a string. We set the shift as a constant to 3. New message, we've created a variable, and then we set up a for loop. For every character that's in the message entered by the user, if the character is a lowercase letter from A to Z, essentially this logic is just 4 lines of logic, right? Because the same 4 lines are repeated in the elif statement. So these 4 lines, what they do is there's something called a Unicode character, right? A Unicode character is basically it's built into our motherboards and CPUs and the devices that we use. Essentially, it maps a number, a unique number, to every key on the keyboard. So even though the plus and equals to symbols are accessed via the same key, they both have under the hood, they both have different Unicode characters. What that means is they both have unique numbers that are mapped to them. And this explains why and how we are able to access each one. So the thing is, the way in which this logic works is that it gets the Unicode character of the character that was entered by the user, and then it applies some appropriate maths and it shifts that character. It finds the Unicode character of the character 3 numbers or 3 spaces after what the existing value is. And then essentially what we do is we attempt to find the character using the chr function in Python. The chr will return Unicode string and ord will return a Unicode point. Okay, so it's basically working forward and backward. Ord will give you the number and chr will give you the character or the string. So I hope that makes sense. And new message is equals to new message plus new char is equal, that's easy. I mean, it's just basically new message. We keep taking each letter and appending it to the string, and that's how it works. And at the end we print the new message. So that was like a really rough overview of the Caesar cipher and the whole concept of cryptography. Super interesting. I recommend you Google it or read up more on it. But at the same time, I recommend you don't, because I look forward to actually giving you the information that you need to know. But super interesting topic. So feel free to do research at your own will. Now let's enter a message. You're going to find that, just for as a test example, I'm going to enter A, and you're going to see that the message it now comes to is actually D, because it gets encrypted using the Caesar cipher. So let's do a complete statement or complete string. Let's do the famous hello world with the exclamation point. So the reason as to why, you see, in some, you're going to come across some code samples or code scripts that show you how to implement a Caesar cipher, but they don't really cater for strings, which means multiple words, and they don't cater for punctuation. But as in our case, we've catered for all. So it's allowing you to view the full effect of the Caesar cipher, because in some implementations of the Caesar cipher in Python, um, the code is available online, but in some implementations they don't cater for the letters X, Y, and Z, right? Reason being, they stop at W, because after W is going to get converted to Z, right, according to the Caesar cipher. And then online code scripts don't really cater for the X, Y, and Z. They fail to map them accordingly. basically they fail to overlap it, because let's face it, right? From X, three letters to the left is Y, Z, A, A. So that's what I'm trying to get at. Some versions of Python scripts online that implement Caesar cipher fail to have that kind of overlap, right? And the reason being is because they tend to do or implement the algorithm using your simple indexing and slicing. That's another way to do it, right? Indexing and slicing. You can implement a Caesar cipher using indexing and slicing, but that's where the issue arises. Using indexing and slicing, the logic is kind of difficult, and it doesn't really give you the full effect and the full professionalism of implementing the Caesar cipher, as opposed to actually getting down to your operating system's code and Unicode characters and sort of grabbing the character by its unique number. That's when you know, like, you are getting it from the root. So that's why this specific implementation of the Caesar cipher will allow us to type all letters and any letter. You can do X, Y, Z, and it will effectively overlap it to A, B, and C, as you can see. So now, enough talking. Let's do a cool message to get encrypted. Let's do hello world. We are learning Python programming with machine mentor Shivek. That's good. Hit enter. Excellent. As you can see, the chances of someone unscrambling this message is pretty, low, because especially now we are talking about this happening in the past, right? In the past, if we were to use this Caesar cipher, the chances of someone who gets their hands on on this message actually understanding what it's saying is quite low. Even in modern day, not many people, I would say, well, especially those who are not tech inclined, those tech inclined people, if you provide them with this string to read, they're not going to know what it is. But now, as opposed to giving a tech inclined person this string, they're going to know that, if you tell them that this thing has been encrypted, they themselves will understand, and they'll know that there's been an encryption algorithm or a cipher that's been implemented on this string or on this message, and that's what's making it look all scrambled. So that's that, guys. Super interesting and informative lesson this was. Nothing too difficult. Um, I look forward to actually, providing full tutorials on these topics, because they are super interesting topics. And with that, I think we will end the video here. Just know that in due time, I aim to post several interesting topics related to technology on my channel. So with that, thanks for your time, guys. Good luck with your work, and I'll see you in the next YouTube video.